See if we got everyone in. Awesome. Welcome everyone to our third official webinar with Whistling Consulting. I want to introduce myself. My name is Ben Peterson. I'm the Director of Sales and Marketing. And just what I love is I can toot our own horn because I was a customer of Scott's for about 4 years of Whistling Consulting. I went through, quite a few different engineering firms before I landed with Scott as a customer and then came over here. So we truly do really honor customers, and we love working with people and building partnerships. And that's what we're looking at doing here. And we're excited to bring you here today to talk about RELD versus RELLIS systems. So we've got our resident experts, Scott Whistling and Heath Harpster. They are both professional engineers, and they have been in the business. Scott since started his engineering firm in 2010. And Heath, you've been in the solar business for 5 years?
Like 2 years now, a little over 2. Slowly becoming an expert.
It feels like 10.
Right.
Perfect. So yeah, we're gonna jump into it and kind of answer some of your questions. Scott's gonna take the lead here. So if you have any questions, note those, and then as Scott wants to take questions, he'll unmute you so that you can ask your questions. Thank you for being here. We greatly appreciate it. Go ahead, Scott.
Thank you, Ben. I appreciate the introduction. Yes, we're going to talk a little bit today about RELD versus RELLIS systems, and I think that that has been actually something that I think we have been dealing with pretty recently. We've seen a lot of a flurry of interest in wanting to use RELLIS systems as opposed to RELD, which we primarily have seen in the past. And I believe that there's advantages to RELLIS system, and there's also advantages to RELD systems. And we're going to talk a little bit about that on our call here. I am by no means an expert when it comes to RELD versus RELLIS systems. And I think I want this to really be more of a discussion than necessarily us trying to, me and Heath trying to, explain what the best product is out on the market and what the best way to handle it is. But we just know that there is a lot of questions related to RELD versus RELLIS systems, and thought it would be a good topic to discuss. We've reached out to several of the manufacturers who produce both RELD and RELLIS systems. We reached out to EcoFasten and had some discussions with them, with one of our customers. In fact, Skyline Solar has had some concerns related to RELLIS, and I think we must have spent, Keith, at least 2 or 3 calls with EcoFasten, and even asked them to do some additional testing for us to kind of confirm some of the things we were initially anticipating, or initial findings. And they were very helpful. And then we also worked with K2 with their products as well, and as recently as just last week. And Bradley Bland has actually, from K2, is on our call, and I've asked him to kind of participate a little bit in our discussion. And a lot of the information that we're even going to talk about is based on even some slides that we have are provided by Brad. So we appreciate all of the manufacturers and all that they do. We're also going to talk a little bit about the Pegasus skip rail, which is kind of a hybrid between RELD and RELLIS systems. So we have some slides related to that as well. So I think it's going to be a good discussion. And frankly, it may or may not even be that we get everything we want to talk about today. This might be something where we continue a discussion related to RELD versus RELLIS systems on another webinar. But we'll try and keep this brief and to the point. So that Whistling Consulting, we are one of the largest engineering firms in the industry right now. I'd like to say that we're an innovator in the engineering realm, and been doing this probably longer than any other engineering firms have been doing it. And with that, we have a certain amount of experience and reputation in the industry, which we want to make sure we continue to excel, and also have quality of what we do, and make sure we're as accurate as we can be. And with that, we do a lot of research on products, including what we're going to talk about today. So this initially spearheaded when we started seeing, actually there's an account that was done a couple years ago here in Utah, in Midvale, Utah, that had some significant damage, like 2 years ago, not this past season, but 2023 to 2024. No, it was 2022 to 2023. There was the worst winter we've had in 50 years out here. We had, I don't know, 9 or 10 feet of snow. Some of the ski resorts shut down because there was just so much snow. So we had a customer of ours who had some solar on his roof, and it was a railless system. And I'm gonna share my screen, and we can talk a little bit about that. And I have some screens here. Give me a second. Can everybody see that? Heath, are you able to see that?
Yes, sir.
Yes, we can see it.
So here's some pictures of this system, right? This is a railless system that was on this gentleman's home here in Utah, and it got completely destroyed from the snow that was on it. A lot of damage. You could see that all of the panels were either cracked or broken or had micro cracking in them from the snow. And you could see that the connectors actually pulled out of the roof, right? Which these are the things that we want to try and avoid. And this is part of why we're going to talk a little bit about railed versus railless systems. And so let me minimize that a little bit more, and let me stop sharing my screen so we can chat a little bit more. So our initial concern was related to specifically this project, and what could we have done differently to make sure that this doesn't happen. So in doing that, we have to look at the manufacturer's information, right? And there's companies that provide the railless system and a railed system, like K2 and EcoFasten and Pegasus and Snap and Rack. All of the companies provide them, and they do testing on their product. But the limitation sometimes is not necessarily on what the product that's connecting to the roof is, but what the panels themselves can sustain, right? So a panel is made out of glass, and at the end of the day, if they're not supported, they could break, which is what happened with this system in Murray, Utah here. So we started looking at the panels themselves and realizing that the limitation lies in the panel. And the rails and the railless system are supporting those panels. And so that's kind of where we started looking at this information. Then we met with people like EcoFasten and K2, started to see what testing have they done, and have they tested these specific modules. And then so they started providing us information, and we found that depending on how you mount them, you can mount panels in portrait, or you can mount them in landscape, right? And I'm assuming everybody knows the difference between portrait and landscape. Portrait is basically the longer edge is parallel with the surface of the roof. The shorter edge is parallel with the ridge, right? So, and then when you put them in landscape, the longer edge of the panels parallel with the ridge, and the shorter edge of the panel is parallel with the roof, or perpendicular to the ridge. And when you start looking at the mounting systems that you use to attach these to the roof, you want to connect them into rafters, right? There's been a lot of, our last conversation was between rafter mounting or deck mounts, right? Connecting connectors into rafters or connecting them directly into the deck, right? And the pictures that I just showed you of that damage, you could see that the connection was only mounted into the deck, right? Which, that was a discussion we had last week or last month, right? But when you're connecting these into rafters, you want to get them in certain points along the rafters, right? And the panels aren't, the dimensions of a panel aren't specific that they fall in line with a rafter, right? So you're not going to get something connected into a rafter and then have it hit a rafter on the same panel. What happens is it tends to be that the connectors are either one on one panel, two on another panel, one on one panel, and then you wind up only having one connection supporting a panel on railless systems. When you're talking about railed, it's not an issue, right? Because the rail runs along the back of the panel, let's share my screen again. We can start going through the deck that we have here. So if we talk about railed versus railless, you've got, this is what a railed system would look like. It's connected to the roof. You connect the rail to the roof, and then the panels are supported on the rail, and they're connected to the rails, right? They have full support along the back. Doesn't really matter. You can put these connectors any place you want because you can hit a rafter. You can put it here. You can put it here, here, anywhere you want. It's easier to connect to the rafters when you're doing a railed system, right? And typically you'll do a 2-rail system. The Pegasus is kind of like a hybrid where there's one rail, the split rail. There's one rail, and then it uses a connection between the panels to transfer the load. And then when you go now into a railless system, that's basically now where you're eliminating the rail and you're connecting directly to the panels. And then in areas where you don't have a support, you're typically putting a connection between the panels, or a bridge, if you will, right? That connects panel to panel. And then we have different types of the railless systems, right? So this one is this is a traditional railless system. This is a mini rail, which K2 manufactures, and this is the skip rail, which is manufactured by Pegasus, right? So you could see a rail on the lower part or the upper part of this panel, and then the upper part of this panel, and then here it's transferred with connections through the rails themselves. And then if you go in there, we have more detailed views of those as well. But this is where you get the information from the panel manufacturers, right? So I could blow this up a little bit. Let me see if I could blow this up a little bit. So you could see that, what rail was this, Heath, that would pull this information from?
It wasn't a specific rail, but it was Q-Cell's installation guide had this.
All right. Q-Cell panel, right? So all of the manufacturers of the panels do testing, and you can see this is a rail where it's supported along the back of the panels, right? Typical rail. In this location, they have a certain distance that they identify off the edge, and they do testing on this, and you can determine what the push-pull or the test load would be. Design load would be a factor of safety applied to the test load. This is in pascals, and I think, what's the conversion from pascals to
typically
pounds?
Multiplied by 0.02.
So 5,400 times 0.02, that's about 108 pounds with a railed system. Now that's a downward force is 108 pounds, and then the upward force would be 3,000 times 0.02 would be 60, right? So
yeah,
you're
60
talking
pounds
about
per square foot. Yep.
60 pounds per square foot.
Mm-hmm.
And then as you move over to now, this is more of like a railless system. You have you basically have them at the corners now or along the edges, right? Depending on where the rafters fall. And in some situations, you may not even have 2 connectors, right? But this test that they did was with 2 connectors. And now you're at 1,200 for downward force times 0.02. That's only 24 pounds per square foot that this would sustain. And when we say downward force, we're talking specifically about snow load. Upward force would be wind lifting the panels off the roof. So 1,200 times 0.02. Okay, it's the same in downward versus upward force here. But you can see a significant decrease, right? What's that? 1,200 divided by 5,400. It's about a 60% reduction in the capacity of that panel if it's mounted in a railless situation now in portrait, right? So we want to distinguish that these are in portrait. You can see that the panel's in portrait. And so that becomes problematic. So technically with this rail or with this panel in a railless application in portrait, the maximum snow load that the panel would sustain would be 24 pounds per square foot. Now, that's a downward force. Now, how that attributes to a ground snow load, right? The code allows us to take a 0.7 reduction on a snow load from the ground to the roof. So that's about a 34 pound per square foot snow load, equates to about a 24 pound per square foot on the roof load, which is what these were tested for. And now that's a test load, right? When you go to the 800, which is a design load, you're more like 16, right? So depending on the slope of the roof, you have some significant limitations as opposed to, say, 3,600 pounds with a railed system. Okay, so that's not to say that you can't use a railless system as opposed to a railed system. I think it's just a matter of the application that you use it in. For instance, if you're using a railless system in an area where there's no snow, then you're good, right? Because you're not worried about that downward force on it. You're worried about an uplift. You just have to check it for wind, and you usually it could work out really well. And we've had no issues with railless systems being used any place where there isn't any snow. But when you start introducing snow, then we said, okay, we need to put some limitations on when you can use a railless system versus a railed system. And the answer is that we just figured it was 24 pounds. So we've limited railless systems in Portrait to only supporting nothing more than a 30-pound snow load, which frankly covers most of the East Coast. When you start getting into New Hampshire, Maine, some areas in Massachusetts that go up to 40 and 50 pounds per square foot on the snow loads, then you're usually pretty good with a railless system in Portrait, right? Now, if you want to get right, and that's basically what we're talking about here. Now, there's better support, like the mini system that K2 produces. It's kind of like a rail system, but it's not. It's a shorter rail, right? Like they have a maybe about a, I don't know, 6-8 inch mini rail that is connected to the roof, and the panels connect just as they would to a regular rail system. So this is almost very similar to the railed system. You can see that the test load is a little bit less than what it was on a full railed system, and I think that's because as these panels deflect under a snow load, it can deflect more in the middle because the rail doesn't come all the way across, right? And so there are some limitations on where they think you should cut it off as far as even one of those systems. But even there, it would still support more than a full railless system, right? And now when we start looking at let's go to the mini system. K2 Mini. I think let's see.
Let me share my screen, Scott. I have a more up-to-date one.
Yeah, go ahead and do that.
Okay.
Heath, thanks.
Okay.
Yeah, so go down to this panel right here. So this is the mini system, and the mini system is designed so it is a deck mount, and you have to make sure that the deck mounts are designed for that force that you would get from the snow load. And there's typically either 3 to 5 screws that would be used on that deck mount. And they typically, we don't want them pulling out. So it's important to make sure you have enough connectors at enough spacing so that it resists the force that would be coming down along the plane of the roof, and want to try and pull those panels, those connectors out. Because that it's an eccentric loading that would want to rotate that panel off the roof, kind of like a moment that we're trying to push it forward. Yeah. So Heath, do you want to talk a little bit about the advantages of it being in landscape then?
Yeah. So I don't necessarily have the numbers from the manufacturers on, what they're good in landscape for. Like the Portrait ones here obviously aren't rated for that much because they're fastened on the short edge of the panel, right? And so you have your glass that's going to deflect from across the long side. and that's where you're going to get a big reduction in that value. But talking with the manufacturers and looking at some other data that they have, if you put them in landscape and you're fastening on the long side, you can get around like 40 to 45 pounds per square foot on there. And so as a company, you know how Scott said that we are allowing the portrait ones to be 30 PSF ground snow load. In landscape, we're seeing around 50, which would equate to about 40 or 45 on the panels on the roof. So if you put them in landscape, you get a little bit more strength out of them. And if you look at the mini rail, is they are mounting on those long sides, so that's where you get a little bit extra value when you're using this kind of system. Like Scott said, though, the limitations on this, because they're in between the panels, is it's pretty much deck mount only. Because panels are usually around like 41 inches wide, and you're not going to hit rafters when you're forced into that kind of limitation.
Yeah, so based on some of the testing that the manufacturers have provided with landscape, our internal what I've instructed our internal engineers and designers is that if it's 50 pounds and less, you can use it in landscape. If it's 30 pounds and less, you can use it in portrait. And you'll see some of you on this call, or even client of ours, who may have, we've pushed back, and a lot of times, maybe not as clear when the manufacturers represent that you can use their product. I think sometimes they don't explain as clearly as we would want them to, the limitations related to it. But we're trying to make sure that we help all of our customers understand that, because the last thing you want is to have a situation like I had here in Utah where the panels need to be completely replaced. And I can tell you that it wasn't an inexpensive situation where whoever installed them, and I'm not going to name any names on panel or the installers that put it in, but they basically had to eat the cost of a whole new system and put it back up on the roof, which was certainly not something anybody wants to do. So you want to be very conservative and very cautious about when to use which, right? The other thing that is important to make a note of is when you do connect these and you're utilizing now those clips that bridge between the panels. And if you could find a slide in there, Heath, that shows where that, yeah. So there's a clip right there, right? Mm-hmm. I wanted to get some data. That's why we might want to do another follow-up on this, but I wanted to find some data on the testing of these panel manufacturers of how much of a deflection it will take before the panels pop out of that bridge connection. And I don't know if it's designed for a certain amount of, loading, like, or deflection, because the panel on the right that's supported with 2 mounts on the edge, and the panel on the left is only supported by 1, that panel on the left is going to deflect more. And at some point, the panel on the right is not going to deflect as much. So it's going to put a strain and a force on that connection, right? And if the connection's between the 2 panels, I don't know if that would really get pulled out, or actually, I think it will. Matter of fact, if you go to the damaged roof section from that Utah project, you could see in the middle of that row, go up, in the middle of the row, you could see where the connection was between the panels, and it's not, they fell out. Like the force underneath on the snow load on these panels made that pop between the panels connections, right? So that's another thing that you also need to be concerned about when we start talking about what can these panels withhold if there isn't a rail behind it. Now, the mini rail system is they don't rely on the connections between the panels to transfer loading, right? So that's not as big of a concern here. But with the typical railless system, they are specifically relying, and even the skip rail, right? If you go to the Pegasus one, there's those connectors above the rail in the middle of that array. That's all connected directly to the panels, and the force that would come across them, the downward force from snow, is going to it's going to have a moment in it. It's going to want to bend and the ones above it are going to bend, deflect more and want to pull themselves out of the other connection. You know what I mean? So you just want to be careful with that, right? So let's go to the next slide.
This one or
Yeah, just keep going. So right here, let's talk about, so we've talked a little bit about what some limitation, go back one slide. We've talked about some limitations, but let's talk about what the pros and cons are now, right? Go to the slide that has the checks on it. Keith.
yes, yeah.
That one right there, yeah. So the rail system, you don't need to worry too much about the snow load, right? I mean, you certainly have to worry on the panel manufacturer itself. Even with a railed system, panels can deflect so much and get damaged enough that they would, lose their ability to generate electricity, right? So that's a pro for a railed system, right? You can do predetermined mount spacing, so you can hit rafters if you want, which are the best connection in our mind, right? You can use deck mounts, and we've talked about that in our last webinar. But
yeah, and on that topic with with the railless ones, is you want to have at least one mount per side of panel, right? And so if you're trying to do 48-inch on center spacing and the panel is only 41 inches wide, you're going to have to rely on the installer to kind of figure that out in the field. Where are they going to have to add additional mounts where the 48 inches on center might not work every time? And so that's kind of what we mean by predetermined as well for the rails, is you have a set idea and plan that's going to work no matter what for the most part.
Yeah, you could basically follow the plan set that was prepared, right? Yeah, if you guys have questions, by all means, go ahead and add them in. And I don't mind even pausing if we have to here.
Yeah, just go ahead and you can go ahead and raise your hand. I do see there are some comments in the chat here.
Yeah, let's see. For your information, the skip
Ian.
rail, the panels are always the failure point. Yes, that makes sense before any module slip. Before they slip out. We've never seen a single failure where the module slips out of the skip rail clamp in all of our testing. Okay, well, that's good to know. And Ian, let's see if we can unmute Ian. Ian, tell us where you're from. Are you from skip rail at this point, or are you just a manufacturer who knows a little bit more about it?
Hold on, I'm getting to him real quick. Where are you at? There you are, Ian. Okay, Ian, you should be good now. There you go.
Hey guys.
Hi, Ian. How are you?
Hey, good. Yeah, so I'm the test engineer here at Pegasus, and I just figured I'd chime in on some of your points there. And you're right about some of the railless designs like that, but yeah, in all the testing I've done, I do see some modules being stronger than others, but I work with module manufacturers to basically come up with warranty acceptance letters, because with skip rail,
we've appreciated those. Frankly, we have not seen those from other manufacturers, but you have actually gone to the extent and gone to panel manufacturers and had them rate it specifically for the system. So there's actually a letter that they produce. If you're going to do it with this system, this is what the panel's rated for. We do appreciate that.
Yeah, correct. And I mean, some panels do better than others, and some are derated to lower loads than other ones. I mean, our system's rated to 2,400 pascals, and some of those thinner framed modules don't fare as well. But yeah, it's our system. There's no installation manual I've come across that kind of covers that type of an installation. They cover railless, they cover every other kind of method, but the whole kind of a hybrid like that style, it's that's the whole point of the warranty acceptance letter. So we do system level testing and stuff to kind of just validate every different manufacturer.
That's great. Yeah, no, I appreciate that, and thank you for being on. I really do appreciate that. And we probably, when we get to some question and answers, would you, I know that I've asked Brad to cover a couple things from K2, and I'm more than happy to have you guys chime in and have a good discussion related to pros and cons. But no, I appreciate your input.
Yeah, no, happy to answer any questions.
Thanks. And if anybody else has questions, by all means, drop them into the chat, and we can always pause and go to some questions if we need to while we're doing this. But we're not far away from being done with our presentation, then we can open it up to questions, right? So, Rail, the other thing we did not talk about is when you're doing a railless system in portrait versus landscape, it's very defined as to what the limitations are. You can go 30 pounds per square foot and less on portrait, and then 50 and less on the landscape. But what becomes problematic is when you start having a hybrid, like you have some panels that are in portrait and then you have others in landscape. And most designs that you put on the roof, you're going to have a combination of portrait and landscape. And then that becomes very difficult from an installation perspective if you're not using a railed system and you're using a railless system. Now, I'm not saying it can't be done, but it is a little more complicated because you have to make sure you have proper support, especially if you're doing it in a high snow area and now you're using portrait. Then you need to make sure that there's something different about those portrait panels that will give you the higher rating, right? So the panels aren't breaking under that snow load, right? So that's one of the other advantage of a railed system, right? So railless system, there's an ease of installation. You eliminate having that entire rail that you have to cart around with you, right? And I've seen pictures of everything that you need to install a railless system is in the back of like a Toyota Camry or a Scion, a very small car. You can pretty much put all of the equipment you need in the back of that, which means you don't need to roll a truck. You don't need to have expensive commercial vehicles. People can even use their personal vehicles for all the material that we need to do a railless system, right? Because you don't have that 10-foot rail that has to be in the back of a truck somewhere on the top of a truck, right? You also have less material. So there is less of a cost associated with having less material. I was trying to get what percentage it would be, but I wasn't successful to have that before this meeting. And possibly if we have another follow-up, we can provide some more information related to that, right? But I would think a railless system is a little less costly to install. The other thing, though, so those are some of the pros related to railless. And the con related to rails, because you do need to roll a truck with that. You do need to have a truck to be able to get the equipment on there that you would need. A little bit, there are some AHJs that require inspection when it comes to rails, right? They want to do an inspection before you put the panels on, and they want to inspect the rail system. And that happened with Skyline on the East Coast, I think in New Jersey. They were required to do inspections on their rail system. So their decision to go to a railless system was more because it needed to be something that they couldn't wait to have an inspection. And inspectors, we all know how diligent they are at running right out to our job sites and making sure they're there and there's no delay. We know that they're really on top of doing that. But I mean, honestly, it could be hours before you see an inspector and you have a crew sitting around waiting. It's just a waste of time. So they decided to use a railless system for that very reason, so that they didn't have to wait for these inspections on the railed systems that they're using. So there's definitely applications that railless systems are by far superior to railed systems, but then there's also situations when railed systems are far superior to railless systems. So it's just being informed and the information that you need to have to make that informed decision related to which is best for the application on your project, right? So I think that covers most of everything that I think I wanted to cover. Just a quick synopsis on these railed versus railless systems. And Heath, is there anything that I missed that maybe
Don't
you
think
can
so.
add in?
I just wanted to step in and say, this is the whole railed versus railless thing seems to still be fairly new, and we're not saying we're experts on it by any means. This is just what we found out so far in our research and what we're going off of. So as we continue to talk with other manufacturers and gather more testing data and more information, our decisions and our philosophy on it is subject to change for sure.
And the whole reason behind doing what we do is for the safety of you guys who are installing this, right? I don't know numbers and costs because what's important for me is more so the safety of the people on the roof and for the homeowner's safety, that things aren't coming off the roof and damaging personal property and even people, right? Our charge as engineers is to primarily look out for the public health and safety, to make sure that people are safe in what we do. And that's really why we review and do what we do. And that's why we go to the extent of doing the research that we do. So, I would love to open this up to the floor. I do want to give Brad a minute or two to kind of chat through a little bit of what he's seen from K2. And I know that their mini system is a pretty good system. And the Pegasus has a great system as well too. So let's give I'd like to give Brad and even Ian, if you have anything else you wanted to interject, give you guys a minute or two to kind of chat a little bit about your product and what your thoughts are on Railless versus Railed. And I know both you guys are aware of limitations. I know I've had several discussions with Brad where, frankly, we might just say, look, use a railed system. It's not like we have to replace a railed system. If it's a steep slope roof and it's hard to install, maybe the railed system is a better way to go because it gives you a little bit more support. Right? Your feet can kind of lean against a rail, not putting a lot of weight on them. But as you're installing things, it's easier with a really steep roof to use a railed system than a railed system, than a rail-less system. So anyway, why don't we unmute Brad and Ian and let them give us a little bit of thoughts on what they've heard so far.
Yeah, guys, it looks like you have the power to unmute yourselves right now, so you can go ahead.
Yeah, I unmuted them. So and if you'd like camera
Yeah.
to be on camera, let me know and I can allow you to be on camera too.
That's fine. I appreciate it, and thank you guys for the opportunity to talk. I would just say, Scott, to kind of follow up on some of the things you and Heath were talking about. Railless has been around for a long time. My understanding is, it kind of got its genesis back from a company called Zep Solar and Solar City years and years ago. And they were really, I think, the innovators of this style of a system. But the other thing that they had going for them at that time is they had a system that was integrated with the module, meaning the module is actually manufactured to work in conjunction with this system. Whereas these days, myself, Ian, anybody else on the manufacturing side, we don't have the benefit of that, right? We are manufacturing products that have to work with a whole bunch of different modules. Hence Ian's comment about, hey, they're not used to seeing a hybrid system. It's typically a rail system or a railless system. And then he's got to go out and test with all these different modules to make sure that it works with them, because of the fact that, they're not coming to Ian or to us saying, hey, what are you guys coming out with as a product? Let us go do testing for you. And, now we'll be, together on that side. We have to create systems that work with all sorts of modules that are out there, right? So I think that kind of evolved to different manufacturers trying to create railless systems to, mirror, have some of the functionality of the original Zep system with varying levels of success. And, Scott, to our conversations this week, last week, this was a space that we really hadn't been in until very, very recently. And I think it was because, from what we had seen with the various options over there, we didn't like some of what we saw in terms of being able to create, an innovative system and something that was easier, let's say, than rail, or really captured a lot of the advantages that I think Railless has tried to do. And for sure, depending on who you talk to in the industry, some people use it, some people love it, and others have struggled and had the same issues that you showed right at the beginning here. And as I also mentioned to you this week, I would be the first to tell you that it's not for every application. There are certainly applications where I would tell somebody flat out, this is not a good idea. The loads are too high, the roof is too steep. You're trying to do this maybe to use one type of system that's going to work on every single application you have. And the reality is there's always going to be asterisks or things out there that, it might stink that you have to use a different system for this application and you can't use the one that you're used to using, 80% of the time. But the reality is that's safer and it's just an overall better sound installation for the homeowner and for the installer. And so, again, it's not for everyone and it's not for every application, but, I think it's come a long way and there's a lot of manufacturers that have created innovative products. Again, Ian's product, we've seen it, it's an interesting hybrid spin on this as well. And so, the industry is evolving and we're learning more and more of what's possible and not. And we also always, at the end of the day, just because you have a good idea doesn't mean it actually is plausible and safe. And so, first and foremost, whether it be K2 or Pegasus or anybody else out there, we've got to do a lot of due diligence and actually create products that are both structurally sound and safe first and foremost before they're going to go on any application, or else, you're kind of defeating the purpose. You can't give somebody something that's going to put them in peril or the homeowner in peril because it's ultimately not safe. And you could have modules coming off the roof or anything like that. That is a much bigger issue in general.
Agreed. Well, thank you. Thanks, Brad. I appreciate your input. And Ian, did you have anything else you wanted to say? And I did not script. Most of this is not scripted. So Ian, if you feel like you don't want to talk, you don't have to talk. but if you want to say anything, you're welcome to chime in.
Yeah, no, I'll just kind of add on to, Brad said it well. As the industry kind of continues to innovate, things are going to change, especially with, module manufacturers. One thing I see is them trying to change, to name one, frame thicknesses and stuff. And, I would imagine for railless, it's going to be the same issue as for mounting, with those clamps and hardware to attach things like that. So it's just kind of an ever evolving target for, as things grow and expand, for ensuring compatibility between just every component. Same thing with UL 3741. That's also a relatively new standard, and we're seeing a lot of growth in that section. And so these systems, whether it be rail free, skip rail, or dual rail, just another whole piece of the puzzle for ensuring that compatibility and just overall safety on the roof and in all situations for high wind, high snow, and fires and things like that. So
yeah. Well, thank you for that input too. And you're absolutely right. It's challenging from a manufacturer's perspective because there's so many different variables now and so many different panel manufacturers and different types of frames that they're using. And I can imagine that there's going to continue to be innovation in the panels to try and make a less expensive product. And that might mean making smaller frames, right? I know that LG has a really, really nice frame system. We look at that in Miami-Dade, right, for the wind uplift there. And a lot of other panels can't meet the same requirements that an LG might, but it's also more expensive. So, I mean, the more rigid you make a panel, the more expensive it costs to build it, and then more expensive from the end user's side. So, yeah, no, there's always limitations.
Yep.
Thanks for you guys' input. Let's open it up to the forum here and see if anybody has any questions. I want to leave, the last 10 minutes or so for your guys is to ask questions of either myself or Heath or even Brad and Ian. I know that this is certainly things that I know you guys have been talking about internally. There's at least 3 of our customers we've had several discussions about this and making sure that everybody understands the limitations before they make decisions. So that's why we have these calls. So and yeah, so go ahead, let's open it up and see who else has any questions. Just raise your hand if you have a question, and Ben will turn on your mic.
Yeah, Susan had made a comment, Susan Stark, about 30 minutes ago that said those are test loads, not design loads. Design loads are even less.
That's true. You're absolutely right. And you
Yeah,
have
I
to
think
be
I think
cautious about
Scott
that.
clarified that too.
He did. Okay, cool.
Yeah.
Just want to make sure it wasn't missed.
Yeah, I think the one was 800, and that makes it even less of a load that they would sustain. It's important to look at those spec sheets you get from the panel manufacturer. I know we just throw them into a plan set because the HJ wants spec sheets, but when you start diving in and looking at them, it'd be great if they weren't all in Pascals, because then you don't need to figure out and go on the internet to figure out how do you transfer Pascals to loads. But it's important that you look at those because it's important information. And that'll tell you design loads versus test loads too.
Yeah, that's typically a factor of safety of 1.5. So you divide your test load by 1.5, and that'll get you your design load. Those aren't always specified on the spec sheets. It's usually the test load. So just so you know that test load is not what it's actually rated for. It's usually you divide that by 1.5, and that gets you what the actual rating is.
If usually you can also go into the installation manuals for a lot of these modules, and you can get a lot more information for their test and design loads, because might not be common knowledge, but these panels, on their spec sheets, that just get thrown into plan sets have, rated for up to 5,400 pascals.
Yeah,
Great.
that's ideal conditions, right?
Yeah, and then you go into the manual and you say, oh, wait a minute, I only get this 5,400 pascals if the rail is installed in these exact locations. That's a part of the testing for skip rail is like, the cantilever values of where you put the rail. It's entirely, really greatly affects the strength of the overall system. And, you can't just be putting rails willy-nilly. So testing the high end and low end of the range of that. So
thank you, Ian. Yeah, that's similar to Miami-Dade is, you're always struggling to get panels to actually work there for their max rating, which would be with rails in portrait. And if they see a landscape panel, then you're getting your plans back because they know it doesn't work.
Yeah. Yeah, I mean, even if you guys can chime in a little bit, tell us what your experiences are with railed versus railless. Are you using railless now? Or are you using railed? And what was the deciding factor? That would be good to know as well, too. So don't be shy. All right. Well, I think this was a good discussion. Again, anybody on this call is more than happy to entertain questions. If you're considering looking at one versus the other, you can reach out to any one of the manufacturers. I know they were very, very willing to talk through it with us from an engineering perspective. Sometimes you can sometimes, not that this is a bad thing, but sometimes they're not as non-partial as maybe Brad and Ian are on this call, right? So that's why if you have an engineer that you're working with, and like Whistling Consulting, you can reach out to us and we can even do some of the legwork. We don't, when people who are customers and want us to kind of research things for them, we don't charge. Like there's no charge for us to be able to research things for you and try and get a better product for you. We're more than happy to help as long as you're a customer of Whistling Consulting. I've said this to all of my customers, ones who are on here. We're not looking to try and nickel and dime anybody. We're looking for long-term partnerships and relationships, and that means that we're willing to go the extra mile and utilize our in-house resources between electrical and structural, and even the experience we have in the field with people who have been installers on our team to help where we can and to be able to help make a better product and a better, basically, relationship. So anyway, I don't have anything else. And if no one has any other questions, then we can end this this webinar. This will be available. We're recording it. It'll be available on our website. We started a blog on whistlingconsulting.com, and you'll be able to see those results as well. It looks like there is a link in the chat for an AI summary of this meeting that may be helpful for you guys as well too. So, well, I'm hoping that this was helpful. And please let us know if you have any suggestions on other webinars. But we're grateful for you guys' support and attending this call today. And thank you very much.
Yeah, thank you guys. And we will be sending an email out with this recording. So we appreciate you. Thank you.
Thanks, guys.
Have a great
beautiful
day.
day.